So you should have your basic trig identities notes and your reference sheet. Okay, so just keep this handy so that we can look at this. All right, so let's talk about what a trig identity is first. A trigonometric identity is an equation, meaning that there has to be an equal sign, so they're all little equations, involving trigonometric functions that is true for all values for which every expression in the equation is defined. Okay, so they're basically little equations that are true statements that are going to help us manipulate when we evaluate. So it says they help us evaluate functions, simplify expressions, verify identities, and solve equations. So there's that laundry list of stuff on your reference sheet. You're not expected to memorize those, but honestly, some of them you already know, and some more of them you will just know because you use them so often. You already know the quotient identities. You already know that tangent is sine over cosine, which means that cotangent is cosine over sine. You already know that sine is the reciprocal of cosecant, and cosine is the reciprocal of secant, and all those. Like, you know those because we've been using them. So this first part is all old business that we're just going to apply a little bit differently here. So it says to use the quotient and reciprocal identities to find each function value. So we have secant of theta equals negative square root of 30 over 3. And I want to find cosine. How are secant and cosine related? They're reciprocals. So if the secant of theta is negative square root of 30 over 3, then the cosine of theta is negative 3 over the square root of 30. And then the rest of that is just simplifying your square roots. So that'll be negative 3 square roots of 30 over 30. And then I can reduce that to get negative square root of 30 over 10. And that is cosine theta. Okay. Questions about that? All right. So then we're going to find, it says if tangent is square root of 2 over 4 and cosine is negative 2 square roots of 2 over 3, find sine. Okay, so are tangent and cosine reciprocals of each other? No, but they are related in the quotient. We know that the tangent of x equals sine x over cosine x. So we know tangent, we know cosine, we'll just have one unknown, and that's sine if we substitute everything in. So, if I substitute in for tangent of x, tangent is square root of 2 over 4. That's equal to sine in the numerator, which I don't know, over the denominator, which is negative 2 square roots of 2 over 3. Okay? So I want to get sine of x by itself, so I need to get rid of this denominator. So I'm going to multiply both sides by the denominator. Do I use the reciprocal? No, because I'm not dividing by this. I'm trying to multiply, so I just multiply by what it is. So I'm going to get negative 2 square roots of 2 over 3 times the square root of 2 over 4. And that's equal to the sine of x. Okay, so what's the square root of 2 times the square root of 2? 2 times 2 would give me 4. So all that in the numerator is going to become 4, so I can cancel all that out with that 4. That means that the sine of x is just equal to negative 1/3. Fractions. You got to understand how fractions work. You got to understand how square roots work. All super old business. All right. So number 3. I've got the cosecant and I've got the cotangent, and I need the secant. All right, well, cosecant and cotangent are not reciprocals of each other, but I do know that the cotangent is going to be the cosine over the sine. Right? And cosecant is the reciprocal of what? Sine. So if the cosecant is 7/3, then the sine is 3/7. right? So then now I have the cotangent and I have the sine, and I can find the cosine. You just have to know how to manipulate them. So cotangent is negative 2 square root of 10 over 3. That's going to be equal to the cosine, which I don't know, over the sine, which is 3/7. Okay. So I'm going to multiply both sides by 3/7. So I will get 3/7 times negative 2 square root of 10 over 3. That's going to equal the cosine. So these 3's can cancel out, and I get that the cosine of beta equals negative 2 square root of 10 over 7. Did I want the cosine? No, I didn't want the cosine. I want the secant. But since I know the cosine, is that going to help me with secant? Sure is. So the secant of beta is going to equal negative 7 over 2 square root of 10. So then I just have to rationalize and get negative 7 square roots of 10 over 20. And there is my answer. Okay. What questions do you have? We good? Okay. So let's look at our Pythagorean identities. So they're called Pythagorean identities because they come from the Pythagorean theorem. If I have a triangle on the unit circle, okay, and if it is the unit circle, like I just said, then the radius is 1, and my x value is just cosine theta, and my y value is just sine theta, right? So then we know how Pythagorean theorem works. It's a squared plus b squared equals c squared. So that means that cosine squared theta plus sine squared theta equals 1. And that's one of your first Pythagorean identity up there. And if we know that cosine squared plus sine squared equals 1, then every arrangement of that is true as well, meaning that I can also say that cosine squared theta equals 1 minus sine squared theta. Does that make sense? Just by taking that identity and subtracting sine squared from both sides. Here's your other two Pythagorean identities that I'm not going to take the time to show you where they come from because you're less likely to remember these than you are to remember that one anyway, and you can use your sheet, that's fine. But the sheet is only going to say this. It doesn't have every other version of it on there. So I could say here that tangent squared theta, okay, so since tangent squared theta plus 1 equals secant squared theta, then tangent squared theta can equal secant squared theta minus 1. Do you understand how I got that from that? Okay. And then here, I could say 1 equals cosecant squared theta minus cotangent squared theta. Okay, those are just a couple, and there's other arrangements of them that you could do, but just understand that this is probably all you're going to see, and then you'll just have to know that the other ones work and figure them out. All right. So let's do one of these. Now it says use Pythagorean identities. So even if you have other ways to do it, it literally says use Pythagorean identities. So that's what you got to do. So if I want to find cosine and tangent, and I have sine, and I have sine is negative 1/3 and cotangent's less than 0. So that right there tells me I got to figure out which quadrant I'm in anyway. Sine is negative, so I know that sine is negative in the 3rd and the 4th. Cotangent is negative in the 2nd and the 4th, so that tells me I am in the 4th quadrant. That's going to matter in just a minute, and I'll show you why. So we're going to use our Pythagorean identities we're going to use this one right here first. So cosine squared theta plus, now I have sine, so that's negative 1/3 squared, equals 1. So cosine squared plus sine squared equals 1. So that means that cosine squared theta plus 1/9 equals 1. When I subtract 1/9 from both sides, I'm left with cosine squared theta equals what? 8/9. So then I take the square root of both sides, which gives me that the cosine of theta equals plus or minus the square root of 8/9, which gives me plus or minus the square root of 8/3, which gives me plus or minus 2 square roots of 2/3. Okay? But then you have to decide, is it plus or is it minus? We are in the fourth quadrant, because it's not both of the answers. It's one of them, but you have to decide which one. Which one is it? Positive, because this is cosine, and cosine is positive in the fourth quadrant. So cosine theta equals 2 square roots of 2/3. Okay? Now, if I want to, so that's cosine. Now, if I have cosine and sine, I could use the quotient identity to find tangent, but it says use the Pythagorean identities. So if I look at the Pythagorean identity that has secant in it, that's this, which is fine, I can use that, but I don't have secant. What is secant the reciprocal of? Cosine. I do have cosine, but I actually don't even want secant. I want secant squared, and I have cosine squared right here. So if cosine squared is 8/9, then secant squared is 9/8. And I don't have to square the square roots and take the reciprocal and do all that stuff. I can just straight up substitute that in. So tangent squared, because I'm looking for that, tangent squared theta plus 1 equals secant squared. And secant squared is 9/8. I'm not squaring it. It's already squared for me. Okay. So then I'm going to subtract 1 from both sides. And when I subtract 1 from both sides, what's 9/8 minus 1? 1/8. So that I get that tangent theta equals plus or minus the square root of 1/8, which equals plus or minus 1/2 square roots of 2. Then when I rationalize that, I get plus or minus square root of 2/4. So is it plus or is it minus? What quadrant are we in? We are in the fourth quadrant. In the fourth quadrant, is tangent positive or negative? Negative. So this is tangent theta equals negative square root of 2/4. Okay. What questions do you have? Anything? Okay. So the next one says we're going to find tangent and sine if we have secant. All right, so the good thing is that we can find tangent using secant because the tangent squared plus 1 equals secant squared. So let's try that. So tangent squared plus 1 equals secant squared. This time that's just secant, so I am going to have to square it. So 6/5 squared. All right, so then that gives me tangent squared x plus 1 equals 36/25. When I subtract 1 from both sides, I'm left with what? 11/25. So that means that the tangent of x is equal to plus or minus the square root of 11/25, which is plus or minus the square root of 11/5. So when you get there and you got to make a decision, you can realize, oh, you know what we forgot to do? We forgot to figure out which quadrant we're in, but that's okay. We can do that now because that's something we have to know, right? So let's see. Secant, which is the reciprocal of cosine, is positive. So cosine is positive in these two quadrants. Sine is also positive, and sine's positive in those two quadrants. So I'm in quadrant 1. Quadrant 1 is always nice because everything's positive in quadrant 1, right? So that means that the tangent of x is equal to the square root of 11 over 5. Now, if I want to find sine using the Pythagorean identities, then that means I need cosine. I don't have cosine, but do I have something that can help me? Secant, exactly. If secant is 6/5, then that means that cosine of x is 5/6. Okay. Then I can do my thing. Cosine squared, so that would be 5/6 squared plus sine squared equals 1. Right, just using my identity. Then that gives me 25 over 36 plus sine squared x equals 1. If I subtract 25 over 36 from both sides, what am I left with on the right-hand side? Well, it'll be positive, but it's 11 over 36. Okay. So I take the square root, and I'm going to get that the sine of x is equal to plus or minus the square root of 11 over 36, which is equal to plus or minus the square root of 11 over 6. Then I have to decide, is it plus or is it minus? Positive or negative? Positive. I'm in the first quadrant, so it's the square root of 11 over 6. What questions do you have? Yes, sir. 1 minus 25 over 36. All right, so the next we have cofunction and even and odd identities. We're not actually going to do the work that goes along with them because that's not how we're really going to use them. We're going to use them more to substitute things in when we're simplifying, and that'll make a little bit more sense tomorrow, so I just left them on here. Because these are new, don't expect you to have them memorized, although if you had to sit down and figure them out, you could see the patterns and it really wouldn't be that big of a deal. And I'll explain to you why these are what they are probably tomorrow or the next day, kind of when it comes up. But more than anything, you should be able to use a reference sheet, and if I give you the sine of negative theta, you should be able to substitute in negative sine of theta for it. Does that make sense? Just you know how to handle those things. So just going to be new little equations that we're going to use, but you'll have the reference sheet every time. Okay? We good? We'll do a little bit more with them tomorrow. All right, your assignment is in Delta Math. The first, 8 questions, which really might be the first 10 questions, because I think 7 and 8 have an A and a B on them. Those are questions that I put into Delta Math, which means you're not going to get multiple on each one of them. You do have 2 shots to get it right. After that, if it's wrong, it's wrong. And then the last parts are actually Delta Math questions where you'll get, more practice there. Okay? We good? All right. Make good use of your time and let me know if you have any questions.